Welcome back. This is video lecture 4 on chapter 49, hazardous materials. It's going to be very brief. Just going to discuss some chemical terms. Okay, vapor pressure. Vapor pressure is the amount of pressure in the airspace between the top of a liquid and the container it is held inside. So it is the amount of pressure in the airspace between the top of a liquid and the container it is held inside. The vapors released must be contained in order to exert pressure. Liquids with high vapor pressure will evaporate much quicker than liquids with low vapor pressures. It directly correlates to the speed at which material will evaporate once it is released from its container. Evaporation increases when air or pavement temperature is elevated. Evaporation rates were also influenced by the wind speed, the shade, if it's sunny or shady outside, humidity, all right, and then surface area of the spill. And that is vapor pressure. When you're talking about vapor density is the comparison of the hazardous material gas to air. Okay, air has a vapor density of 1. If the gas is heavier than air, it will sink into little valleys and ditches. Propane, butane, and carbon dioxide are all heavier than air. So if you have a propane leak, a butane leak, and a carbon dioxide leak, you can't expect it to just raise up into the atmosphere. It could stay very low and affect many people, and it can actually sink into lower areas. If the gas is lighter than air, it rises and dissipates. So your anhydrous ammonia, which is still a very nasty chemical, acetylene, methane, and hydrogen are all lighter than air. Even though those can dissipate, if you have a leak, it could still affect a lot of people. Your flash point. Flash point is a temperature at which a liquid fuel gives off sufficient vapors that when an ignition source is present, it will result in a flash fire. All right, so your flash point is the point at which a fire can result from some sort of leak. Flash fire will go out once the vapor fuel is consumed. Low flash point liquids typically have high vapor pressures, and they can be expected to produce a significant amount of flammable vapors. All right, so the flash point is when a fire can occur, and it will burn off that vapor. Ignition temperature is the temperature at which liquid fuel will ignite without an external ignition source. Flammable range is fuel-air mixture that reflects an amount of flammable vapor mixed with a given volume of air. It's the fuel-air mixture that reflects an amount of flammable vapor mixed with a given volume of air. The flammable range is identified by upper and lower limits. Lower flammable limit is the LFL. Upper flammable limit is the UFL. If a given fuel-air mixture falls between the UFL and the LFL and it reaches an ignition source, there will be a flash fire. So if the given fuel-air mixture falls between the upper limit and the lower limit, you're going to have a fire. Specific gravity. It must be determined when applying water to a chemical, and determines whether a hazardous material will sink or float in that water. HAZMAT teams in many cases can cool down the heat or dissipate the concentration of vapors with cool water. Before water is applied, the team will decide if the material may be water reactive or water soluble. If they choose to use water, the hazardous material specific gravity also must be determined. If a HAZMAT team wants to know if a hazardous material will sink or float in the water, they have to know what the specific gravity is before they use that water. Toxicology terms. You have your threshold limit value. Threshold limit value is the maximum concentration of toxin that someone can be exposed to for a 40-hour work week over a typical 30-year career. All right? So if you're working in a situation where there's a lot of chemicals, you would want to know what your threshold limit value is. You might want to see if there's any other jobs available, if they're trying to determine how much of this chemical you can be exposed to over 30 years. But if you have no other options, that's what you're going to have to know is the maximum concentration of toxin that you can be exposed to for a 40-hour work week over a 30-year career. So don't work any overtime. Established by the American Conference of Governmental Industry Hygienists, permissible exposure limit is the corresponding value established by OSHA. So your permissible exposure limit is the same as your threshold limit value. And your threshold limit value short-term exposure limit is the concentration that a person can be exposed to for a limited number of brief time periods. Threshold limit value ceiling is the concentration that a person should never be exposed to. So that concentration can cause some serious ailment. Threshold limit value skin, significant exposure from an absorption due to direct or airborne contact with material. Direct or airborne contact could result in significant exposure. Lethal dose. That one is pretty obvious. It's a single dose that causes the death of a specified number of the group of test animals exposed by any route other than inhalation. Would be your lethal dose. Lethal concentration is the concentration of material in the air that is expected to kill a specified number of the group of test animals when administered over time. So legal dose is anything that's not in the air, not inhalation. Lethal concentration is in the air. Immediately dangerous to life and health it means an atmospheric concentration of substance that will pose an immediate threat to life, irreversible or delayed adverse effects, serious interference for team members. All right, so if you see something is immediately dangerous to life and health, you probably want to stay away. So some of these are more obvious than others, and those are the HAZMAT terms that you need to know.